Hello everyone, it's Sean and welcome back to Having Fun Repairs. Now, it's been a while since I've done a face-to-face, and what better way than to do one over this AV receiver you see kind of in the background right back there. Its center channel is not working, and we're going to verify that here in a minute as I unbox it and we start going through the process of repairing. Now, the main reason why I'm doing a face-to-face with you, and as you can't tell by the title alone, this is part one. Okay, so that means that there are going to be more parts to this repair. And the reason for that, primarily, the first reason is there's not a whole lot of source material to work off of unless if you actually work at Denon or Marantz, I think actually owns Denon, and have repair schematics and diagrams. I'm pretty sure you can find them online and pay for them, but you know, I couldn't find any for free to say the least. So there's a lot that I need to explore while doing this repair to figure out how the components and all the boards inside of it work and interact with each other electrically. Okay, so primarily the first point is to go along in the troubleshooting process in exploration and methodically go through some things and look at different signals to help myself along with the repair. So it's going to serve as a bit of continuity, to be honest. The second reason is Denon uses a lot of components that are manufactured in China, and that's not necessarily a bad thing at all. When you live over on this side of the world, it could potentially be a bad thing if you don't have a local supplier. And a lot of these components that I'm going through this repair, I find don't. Okay, so if you have to order something from China and then it, gets in from overseas, you got customs, you got all those delays and all those things. Well, I kind of want to explore if I can find form, fit, function, or suitable replacements for this AV receiver that I can buy locally that will work and get it functional as well. So that's the overall intent. Now, I understand when people come to the YouTube and they're looking at how to repair something like the center channel being out in their Denon receiver, they're probably looking for a 10-minute video that says, this is what's broke and this is how you fix it. Well, unfortunately, there could be many failed components that can create that situation. So for myself, this is also going to serve as continuity as to what all components, or a good majority of them, can cause this center channel to go out. That being said, let's get to it. And here we go with the actual eBay listing, recording this right off directly from my phone. Denon 7.2 channel 95 watt AV receiver, model number right there, AVRX 2700H. It's a pretty nice receiver. There goes the price. Put in a lower offer and he accepted that lower offer plus the shipping, so got it a bit cheaper than what it was initially stocked for. Condition: parts not working, and what the seller described as the center channel does not work. Everything else is working on it, just not the center channel to my knowledge. Includes all accessories in picture, including the HDMI 2.1 8K adapter for the 8K port on it, and then nothing else significant there. For the rest of the picture, scroll over. There you go. Back. Well, I mean, we'll be seeing a lot of this later, but yeah, looks like it came with all the accoutrements, whatever, complements of accessories. So yeah, let's get it and test it out, see if it powers up. It's got it over on our isolation transformer variac dim bulb tester. We'll test it out, and the red light is on, so that's good. Now this might not work. The only reason why I'm doing it this way is just because, if there's a direct short, that light bulb is going to get bright super quick. However, there's a lot of inrush current to turn these things on, relays, etc. They have to click over, so it might not fully power up when connected to something that is current limiting. But we will attempt it. All right. Yeah, that's not gonna stay powered up. As a matter of fact, there you go. You can see it's too much current's being drawn. So we'll shut it off and get it off of here. And I'll plug it right into the isolation transformer. Still be safe, but this is going to give us a good indication that I don't want to trip anything around the house. And blinking white light. Yeah, and there goes that big relay that was trying to click on earlier but couldn't because we were limiting our amount of current that we could draw. So yeah, it looks like it is turning on. Let me see if I can get a 1 kHz tone or something in this somehow, and we can check out each speaker. Alright, so I got a 1 kHz tone connected over Bluetooth to this, so we're actually testing two things with this. One, it does the Bluetooth receiver in this work, and it does, so long as the provided antennas are attached. But the right channel seems to be working, and I'll just work my way through each one. This is front left channel. It is working as well. And unfortunately, I get no audio out of the center as prescribed on eBay, and then none out of the left and right surround. And then because it's 7.2, let's see, we also have surround back left and right. A bit hard for y'all to see probably right there. So now these probably won't, a strong potential that these aren't going to work with this test unless if I put it on all speakers, if that's an option. But this center channel should definitely, just with this test, it should have audio coming out of it, and it does not. But the left and right channels seem to be working just fine. So I'm gonna read to see if there's any way to get it out of all speakers, and then see if those other channels will come to life. Alright, I found my way into this front menu. Into this menu to assign your speakers. The front was set to large. The center one is showing none. Let's set it to small. Hopefully that wasn't the issue. Subwoofer, yes. Surround, small. And then our two extra speakers, small. Alright. I got this currently in the front left. So we should get static here. And we do. Let's move this to the center channel, see what we get. Yeah, and absolutely nothing on the center channel there whatsoever. Okay, let's go to the front right. Front right is working. Surround right. On 1 second. Got a kid out of bed, and he should be in bed, not out. Asking for things. Okay, surround right is right here. Yeah, that guy's working. Surround left. Surround left is working. Alright, now our last right speaker, surround back right, or FDR. I think I hit something I shouldn't have hit. Yeah, bumped our cable, I guess. I gotta go back into the menu. I'm not getting anything out of that one. Hold on a second, let me double check, make sure I got it connected.
Yeah, most definitely connected, and nothing is coming out of that speaker. So let's switch it over to the left. And if I had it plugged in the wrong place, you'd be hearing it now. But we can move this over. Ooh, that's just bumping this. Okay, so we most likely have an issue with these speakers as well as the center channel. So we may have a bigger issue at play here. Shouldn't just reset itself like that. Let me get back to that menu. Yeah, the left one is working just fine. So we've actually got two speakers that are out. Our distant, far distant, right, or whatever the FD stands for, and our center channel. Wonder if I plug this back into here, I realize I have, technically speaking, that speaker in backwards. I wonder, just by plugging this in, is it going to reset itself? Alright, let's go back to the right one. Oh, now it works just fine. Weird. Let's go to our center channel, test it one more time. That relay kicking off. I think we got a bigger issue at foot here. Either that, I need to get off the isolation transformer. We'll see how it does after we get the that one channel repaired. Yeah, confirmed, definitely nothing in the center channel. So let's get this apart.
Okay. Several hours later, and I've got at least 4 daughter boards removed. And spoiler warning, I have not found the issue just yet, but I have somewhat gotten a little more familiar with the architecture in here and what's going on. So I'll kind of walk you through that briefly, as well as some tests that I've done just with my multimeter. All right, so first off, when you take the cover off, as mentioned, you essentially have this board right here. Okay, this is managing, as I mentioned, your Bluetooth, your network, digital audio in from, say, a TV over fiber or coax, and of course your HDMI. So you've got all your timing chip, decoding, all that stuff happening here on this board. Okay, and then obviously outputting to this board over here, and you know, with other connections coming in, so for power and etc. But I'll set that aside. It's just a brief explanation. Underneath that one, you then are exposed to this board right here. Okay, now this one is going to be your it's going to manage your analog video. So basically composite component video in, and you got a component video out, as well as a RS-232 straight cable for most likely some type of a remote PC function or management, and IR for your remote control in and out. Okay, pretty simple, this one. Again, this one's analog video, and then of course outputs again, kind of going to this board back here, but you know, this is doing all the decoding of your analog video. Then you have this board right here, much smaller one. This is all your analog audio. Again, analog audio in. For the most part, yeah, audio in, except for these four right here, which are pre-outs for your zones and additional subwoofer. Okay, if you so choose to use your pre-out section. But regardless, again, analog audio. All that just to expose everything that you see down this way. Okay. And so, like I mentioned, you know, I think the problem is most likely going to be here in the amplifier section. However, I needed to trace quite a few things out because those boards, this sits down here like this, in this fashion over here. Okay. And I noticed this cable coming from here to over there. I'll bring this up just a smidge, here to there. Okay. Basically identifying your 7 different channels. Okay. And so I was thinking to myself, well, is this an output to here and then, you know, these other boards? But lo and behold, you know, it really didn't make sense once I found out, well, these ICs are here and these are basically, what are they? NJU 72343. If you were to look this one up, and this is exactly the one where the center channel comes through. This is an 8-channel volume control IC. So and when you look at the pin out, your center channel shows up on pin 26 as an output, which corresponds to this cable going to here. So this is actually taking any audio from either your digital audio or your analog audio, provides volume control, and sends that audio over to here, or at least the volume control for the audio is coming to here. If not, the audio is making its way over to here by a different way. Okay. So it's quite possible that the volume control is used to basically control the level of amplification with the audio coming in a different way, instead of it just, you know, acting as a gate per se for the audio and how much is applied in. So it's basically a control board for your audio. That's kind of how I'm looking at it. All right. But you know, exposing all this was important for me, basically, so I could see everything that was going on here. And then finally realizing that your actual audio out is coming from this cable here, at least for your first 5 channels. That reverses and comes to the board here. And then your 6th and 7th channel. And I think your subwoofer. No, the center is not connected. 6th and 7th channel comes from here. Subwoofer must be come somewhere else. And that's going to go right down there. Okay. So these 2 cables right here are essentially the output. And I'm glad that I exposed this, because now I understand that essentially, you know, main amplification is occurring here. Volume control is occurring over here on this guy, right? As the audio comes in, it's fed through various coils and capacitors, etc. And then our relays, as we hear switching over, are most likely controlling need to energize to allow audio through to your outputs here. So I think it's very possible that instead of it being an amplification issue, that it could be a relay issue
especially as when we were touching this, the back, remember, it would shut itself off, and that's kind of indicative of a bad relay, I would think. So I'm hoping it's not a relay. I'm hoping it's a power issue, because if it is a relay issue, well, this is going to be kind of a pain to get to. More additional screws have to come out just to be able to unseat this board and pull it out. But there's not enough wiggle room between the back side of this PCB and your amplifier PCB. So you actually have to take this out in order to remove this as well. But now that I got the architecture down a little bit, I can reassemble it, and I can start checking audio kind of in reverse of what I was originally saying. I was going to start at the output and move inward. It makes more sense now to start at the output here, or the source here, and move outward. Albeit once I have all these boards back in, I'm not going to be able to access everything down here, and I need the other boards in, at least to get audio into here, unless if I can somehow, didn't mean to hit the camera, inject audio from the front through somehow. I don't know if it has that option. I'll have to look up. But I suppose that's the game plan. Now, as far as component testing goes, I did go ahead and then across these capacitors here, they're all measuring about 2 to 3 nanofarads. So red probe, black probe directly across while in circuit. So I don't think that's going to be an issue. If you notice on this bottom PCB as well, I mean, you've got, it looks like something is spilled in here, but I highly doubt that's the case, because if it spilled from the top, it would have to have shown up on those other PCBs, and I'm not seeing anything that looks like, you know, a soda or something, some kind of liquid that, you know, hit the top of them and then ran down this way. So most likely this is just a part of the conformal coating for this board. At least I'm hoping. Okay. As thought, when you see these a series of diodes like you do there and there, that's additional rectification. If I had to make a guess, one is going to be a lower voltage positive DC voltage, and the other one's probably supplying a negative DC voltage. But again, just a guess. Okay. I've checked all my fuses throughout here. We've got 4 here, 1 there. Focus. Come on now, focus. An additional 1 back here. All those were checked out. As far as other things tested, well, primarily you have voltage regulators down here, and what I did is I put red probe to ground, black probe to each individual lead, put it into diode mode and resistance mode, and just compared what I was reading, if you can focus, across each of these voltage regulators, and some of them are the same, so that made for an easy comparison, and they tested okay. I think one of them was different. KIA was this 7805B. I think this one over here was a 7805B as well. 79 PI, no, it's this one right here. If I can get this out of the way, yeah, 7805B. The only one that was different from all the other ones is this 7807B. But you know, nothing really stood out to me there. And then up here at the amplifier, and this is where I'm kind of like, man, I really hope it's not a relay. I hope it's something up here. Ooh, my phone, didn't mean to drop it there. You have all your essentially, you know, if I had taken a guess, Darlington amplifiers, you know, push-pull configuration most likely, then you know, a power transistor smack in between them to provide regulation. But you know, again, red probe on ground, black probe off of each lead, and you see that they're in a series. You got a left big one, a middle small one, and a right big one. So that would be controlling one speaker. Again, somewhat of an assumption, but it mimics that pattern all the way down. Okay, and they all, those pins basically measured the exact same thing. So it might not be the amplifiers, it might just be these relays here, and maybe something did spill in from the side or something instead, and got down into here and potentially ruined a relay. But you know, I kind of hope that it's not that, but if it is, it just, you know, that's what it is. Let's see, this one is a 981 2A 12DS, 981 2A 12DS, 981 2A 12DS. So they're all 2 amps. That's most likely what that 2A stands for. 981 2A 12DS, probably 12 pins, individual pins. Yeah. The only relay that's slightly different, if this is a relay, it might not be. 2 amp 30 volt DC, 1 amp 125 volt DC, and oh no, that might almost got a label of K down there, I think. It's kind of hard for me to read. I'll figure that out, but this might be like a power relay instead. Yeah, it's definitely going to be a relay. What is that? HFD27, and then it looks like a slash 012-8. Yeah. But that's kind of where I'm at. I'll get this button together, we'll get some audio in it, and we'll start scoping out some things from essentially here, and then if I can somehow fit my scope down into here, you know, check from here, and then we can, over on this board over here, we can look with an O-scope at the volume control to see if there's any difference down at this connector here, and it's well labeled. Some things to at least look at, hopefully I'd at least get us in a direction on where our failure is at concerning the center channel. I mean, the more I work on this though, I'm kind of asking myself, has somebody worked on this before? You got this elastic here from this cap that's been broken, but all these, I don't even know what name brand this is. They have this bronze or goldish color foil on them. Like, look at the standoff of these capacitors. And why is that? Generally speaking, you want your negative terminal as close as possible to the termination point. So why are all these, I mean, it's every single one. Why is this standoff on them so far? And these little, you know, black capacitors aren't that far out, but these have all been, you know, kind of pinched in the center and then fed through the hole. Is that just how it's manufactured? Now, I don't suppose, like, if they're dealing with audio, that any of these caps would be harmonic at all, you know, if they're jostled around or anything, but I don't get that design point. And then, like, when you look on the back, I mean, there goes a good example right here. This cap. Look at the leads. Look how long they are. Look how long those leads are. Why weren't they trimmed?
I don't understand that. I mean, you know, I hope it's not more down there. It doesn't appear to be, but you know, that's a good way to short out a capacitor. Having exceptionally long leads. I mean, you got other ones that are kind of that long too. That doesn't make sense to me. All right, so what I've done is I've gotten them buttoned back together in 1 kHz tone, generating from my phone over Bluetooth back into this guy, and got it on Bluetooth, and then I set it to multi-channel. So essentially we should now have that 1 kHz tone out of every speaker minus the one that is missing, and we'll see that here. There goes our front right speaker. We have 1 kHz tone at 3.2 volts. Front left, 3.2 volts. Center is missing. Surround right. I'm going to need to move my ground clip. See if I can just do this. Surround left. That channel is slightly lower than the surround right one, but I'm also using a different ground, so that might be the difference. As well as surround back and surround back left. So. And it could also be in the software that those channels, the dB gain is set differently, but with the audio present, and we see roughly 3 volts coming out, that means that anything prior to that prior to the last stage of amplification should be a lower voltage and amplitude. So I'm going to try to reorient this so I can get up in here and check the pins coming out of this amplifier. Give me a second. There. Should have a good angle on this now for y'all to be able to see too. Or hopefully good enough. I'm kind of coming underneath this post right here. See if I can't get an angle on that first pin. Yeah. Definitely have 2.9 there. It's going to be the center one, which is the third from the top. That will be our center channel. So those channels are there, and this one should be our center channel. And would you look at that? We do have center channel coming out of the amplifier section. So that audio is making its way down to the board there. And if I had to take a guess, based upon that inspection, probably going to have to replace some relays. So I want to at least get those on order, and we can pull that board out and do a better inspection. But that means gutting this entire thing. But before I take everything back out and get that board out of the bottom, you know, I mentioned probing the volume essentially from that IC volume control. And I kind of want to do that, even though we've determined that audio is coming out of the amplifier and going down there, and the problem is most likely on that board. But I want to do it primarily at minimum for posterity reasons. I've not worked on a Denon AV receiver before, being honest. So it'd be nice to have something to go back and have a comparison with. And if not for that, then primarily just to satisfy my own curiosity. But I'm coming down to the pins down here, and read out the first one. It's FL pin 1, supposedly. Let's see, 15 pins. Yeah, pin 1 should be front left. We can take a look at it. And yeah, it looks like I need to reduce. Let's take it down a bit. Yeah, so we got a small sinusoidal waveform there. And I take this a wee bit further down, 4 millivolts. There we go. And I'll start the menu off. And as I adjust the volume, does that change anything? Yeah, it definitely does change my volts peak to peak. Alright. So that is front left. Then we have a ground at pin 2, and then pin 3 should be surround left. Yeah, same thing there. Excuse me. Let's see. Pin 4 is ground. Pin 5 should be our center. So 1, 2, 3, 4, 5. And no, we're not getting anything there, but oh, got something briefly. It's way too low though. So again, because of how this fed, this is the output of this card, and obviously the input is coming from this board down at the bottom. Volume controller. We get it way up there, we can start to get some audio, but something is dragging that audio signal to the ground. So I'm now starting to wonder, is it necessarily those relays, or is that kind of liquidy looking stuff that we're seeing at the bottom, maybe even though they don't look like they're bulging, maybe that's maybe those capacitors got super leaky. And if that's the case, that would explain this, because you know, with a leaky electrolytic, it's going to essentially shunt your AC to chassis. Okay, so it's basically grounding out that sinusoidal waveform, grounding out your audio to the chassis. Let's see. So 5 was center, 7 is surround right. We'll just check one more. 1, 2, 3, 4, 5, 6, 7. This should be, yeah. And again, we can see as I adjust the volume control how that has an effect. All right. So this is probably at the AC waveform is probably, you know, basically like a pre-gain, I would say, with the volume pot before at the output, most likely controlling, you know, pre-gain from whatever audio is coming in here currently connected to Bluetooth, and then obviously further amplification. How exactly it's using that to you know, control the amplification, I don't know. I would need a schematic diagram to have a better understanding, but you know, this at least gives me a little more to go on, and it provides me with some more data in case if I work on this in the future, or similar AV receivers in the future. But for now, it's going to be taking all this out and seeing what we can address down here at that very bottom PCB.
I was actually able to just take the back plate off, which made getting out of that board a lot easier, and I didn't have to remove this amplifier assembly, so pretty happy with that. Staged all the parts here, and we can get back onto this underneath the overhead cam.
All right, so I did notice a spot on our board that appears to be a burn mark. Just right in here. Yeah, you can see that the laminate on the PCB is burned away. We've got a diode right beside it. I realize I'm measuring this in circuit. See that over there? 0.2. 0.2. And there's one to the right of it that's oriented in a similar way. There, UF04. UF04. We can check it as well. Yeah, basically 0.2. Almost 0.2. Do see, do we have a ground somewhere? Here goes a pin 2 off of over here goes a ground. What do we get here? 21 megohms. 21 megohms. Let's go check the other one again. Yeah, 21 megohms. And 22 megohms. Climbing. But for the most part, this appears to be okay. So it's on the other side of this guy. Let me flip the board over. Hey, so if I flip the board over, my finger is literally in between the posts of this relay right here, and that is a relay corresponding to our center channel. So it is most likely this relay needs to get replaced. I'll have to remove it. We'll take a look at the underside of it, but the question remains, what caused the relay to fail? And with as much of this shiny stuff that's on the board, I'm willing to believe that maybe we had some leaky capacitors that caused a little bit of a overcurrent through this relay that caused the failure. So this might be a candidate for a recap job and replacement of the relay. So probably going to off camera, just take my voltometer and just look over a few capacitors and do a comparison. But for now, I'm definitely going to mark this guy. He's going to come out. And if I find anything that looks too far out, I'll mark them as well, and they will come out too. Capacitors. Why is it when you're looking for specific values, it's never the values that you have on hand? I mean, I was able to find some decent substitutes at a higher voltage rating, but I kind of don't want to get squirrely like that. These two from reputable sources, and then I could just use these Amazon purchases for a few made in Zonson, or however it's pronounced, or some Bojack. But this is oh, my daughter's paid a visit. Yeah, hold on a second, baby.
I I don't know the longevity of these capacitors, and I'm pretty sure a lot of these would work. But given this is something that I'm using, you know, no different than a customer. If I was just mocking up something to test, you know, a little cheaply made amplifier or something like that, I'd have no issue with using these. But given, you know, the use of this, I want some longevity. So I just don't know the lifespan of these Amazon capacitors. So I'm not gonna use them. I'm not gonna get squirrely with these. I think I'm just going to order up some from a reputable supplier.
And I also want to test these voltage regulators as well. So I made myself kind of a little bit of a test jig or whatever you want to call it, using my benchtop power supply. Okay, over here, you see. And then essentially, we're going to check to make sure that these things are regulating. And I'm leaving it in circuit because I don't want, you know, just to directly inject the voltage without something in circuit also, you know, limiting the current as well. So I know that the 7805B, the center pin, pin 2 is ground, pin 1 is the input. And based off the data sheet, the max in is 10 volts, and it should regulate me to 5 volts on the output. So over here on pin 3. So I'll start to increase this. And at 3 volts out on the supply, I'm getting about 2.7 out of the voltage regulator. You get a bit above 5 volts. I'm at 4.3 as you see there. 6 volts, I'm getting closer to 5. All right, so I'm at 6 volts now. At 7. Seems to be fully regulating right around 7 volts. And not moving up, so that one seems to be working. All right, I'm drawing about 30 milliamps off of that one. Well, let me go check this one over here in the same way. Doing this the exact same way. And then nothing till we're about at 3 volts on this one. And 5 volts, I'm at 4.3. 6, almost 7, I hit about 5. And then I'm regulating there at 5.03. Benchtop power supply is not showing that I'm drawing any current though. That's pretty interesting. I want to do the same thing for these other ones. So like this 7807B, its max input is 12 volts and it should regulate to 7. And doing the same thing. It starts to develop a voltage right around 3.5 volts. At 5 volts, we got 3.6 out. 6.5, we got 5.2. 7, we got 5.6. 8 volts, we're getting 6.8. 8.77 volts. And as I increase, it still regulates right there at 7 volts. So that one should be good. That's all there is really to these. Again, if you're going to do something like this, I would recommend you do it in circuit, keeping your hands free of any capacitors, etc. But and there you go. Now you might be asking yourself, well, how do I do one that requires the inverse polarity in order to regulate, like this 7907 PI and 7905 PI. They require a negative 10 DC on the 05 to regulate to negative 5, and then up to negative 12 on the 7907 regulates at 7 volts. Well, you could use, if you had a arbitrary waveform generator like the one I've got up on display here, you could set it to DC. We'll change the frequency to 60 hertz just because it really shouldn't matter too much, but 60 hertz. But I set my offset here to 0.1, okay? And still, ground is pin 1, the in is pin 2 on these. The output would be at pin 3. And then we'll just, with the multimeter, go across our ground pin. Try to do this one-handed. It's very hard to do leads one-handed. And then the output pin, and then I will sweep this downwards. There we go. We're starting to regulate a little bit. My multimeter covered up. It is. Let me find a better spot for this. We put it right here. Okay, so hopefully y'all see that. The ground lead again, positive lead. There you go. Oh, put it all there. Yeah, it's a bit. Sometimes it's a bit hard to do leads one-handed. But yeah, let me keep going in a negative DC direction. Find ourselves at negative 3, at 1.8. You can see as I spin this, what is occurring. Oh, 4.6 at negative 5.4. And we're hitting about negative 5 volts now, and about negative 6. And it appears to regulate right there at 4.9. So this one is good. Here we go. And I can do the same thing over here on this side. As a matter of fact, you could probably do this exact same thing, well, barring capability of your signal generator for your other voltage regulators too. The previous ones that we did. But this one should regulate to 7, and let's see if it does perform its function. And we could call these guys good if they do. All right, so again, am I on here? I'm not getting anything. Yeah, there we go. Wasn't on the ground. Now I can hold it. Again, you can see what is occurring on the screen as I increase. This one should regulate a 7. We're getting close now. Right about 8 volts, it appears that we're starting to regulate right there. Negative 6.9. So that's our 7 volt one, and it appears to be regulating to me. So I think we are, I believe those guys are perfectly fine. So I want to talk parts for a second. The capacitors and everything, no issue. Got them all off of Mauser. However, when it comes to the relay, there are very few suppliers, primarily coming out of China, and then whatever distributor you can find online within the country you live. Very few distributors I could find here within the States, and most of those distributors list the part as not in stock or low stock. I, however, was able to get 6 on order, and what was actually ordered was this 981 2A SPF7, or 12, what is it, 12DS or whatever dash SPS7. And that is the actual part. I was able to get, like I said, 6 on order, 4 of which are on back order, 2 which if processed should be shipping, but I have no clue when they're going to come in. It's maybe the distributor is pulling them from China. Maybe they actually do have them at their warehouse. I don't know, but you know, the tracking information was iffy, so we'll see what happens with that. And so I got to thinking, well, you know, if Denon is, you know, putting in components that are essentially, I don't know, facing obsolescence issues, can I get something comparable to be able to use in its place? And so I did find a data sheet on the 2A 981 series relays. Okay, the 2A actually doesn't stand for 2 amps. It's actually the form configuration, stands for 2 form A when you do the research on it. So any relay that you're looking to find needs to be in that same you know, pin configuration 2 form A, which essentially relates to a double pole, single throw, and then NO contact on the other side. Otherwise, it's going to have 8 pins versus 6, which is actually what you need. You need the 6-pin configuration. Now, in order to find a suitable sub, which I did find one that was comparable, this G2RL, and we'll fill in the rest of these a little bit later on. You can see that each, well, first off, you can see that, is it on here? Yeah. Each number represents something. So 981 is the model number, 2A contact arrangement, 12 being the coil voltage, D stands for coil type is DC, and then S is, you know, the enclosure is sealed. Okay, that makes sense. This is a sealed enclosure. So corresponding to that, what I did is to G2RL, right? And we're talking about a double pole, so 2 pole, 2 would be the very next number. Contact form would be, you know, 2A, although this says a single pole, that's not the one I got, that's a 1A. So I got the 2A, which was double pole, single throw. Enclosure type is going to be sealed, you know, those are things that we can make the same. And then, of course, you got some other things over here that's included on this part number that's not included here. But this is a 12-volt relay that I found comparable to here. Now, there are a couple things that you need to keep in consideration as well, or at least what I considered. So let me go over some things that I considered when setting this up. Okay, let's look at the DC standard coil rating. So 12-volt nominal voltage. Coil resistant 270 ohms. Pickup voltage 9 volts. That's the voltage needed for the relay to actually actuate, and then it should drop out at 1.2 volts. Nominal current 44.4 milliamps. So need to come over this way, and we'll check out the other one. No, I found it earlier. Where's that current rating? I feel like it was closer to the top. Yeah, this was it right here. Rating coil. There we go. 12 volts. This was the standard, not high sensitivity, but 12-volt coil. Coil rating here is 33.3 with the coil resistance slightly higher at 360 ohms. Must operate voltage 70% of max, so 70% of whatever 12 volts is. What does math show in my head? 12 times 0.7, so 8.4 volts, so slightly lower than the 9 volts we have over here. And then if you're looking at your must release voltage, well, if it was the high sensitivity, we would be looking at 1.2 volts. The standard one is 10% minimum, so 10 to 41%. 10% still, of your 12 volts is like what, 1.2. So there you go. Should work as far as the release voltage goes. I think that's pretty good. But I annotated the difference here. Coil resistance being slightly higher. Okay, cool. We're drawing less current than this one, but the testing of it was relatively different. So over here, the way they tested that was a max continuous voltage at 20 degrees Celsius. Okay. And what they did is they did 30% over the coil normal voltage. So 30% over 12 volts to come up with that 44.4 milliamp measurement. So, in my head, I'm thinking, well, if you're increasing the voltage, you're probably drawing more current through that coil as well. Depending on its characteristics, how much current it's going to draw through. You change one thing, you kind of change other depending on the resistance of the coil, right? That's going to be, that resistance shouldn't change, okay? But over on this other side, the rated current coil resistance was measured at a temperature of 23 degrees Celsius, so a slightly higher temperature. But they didn't go over voltage. So to me, in my head, I think it having a lower rated current, despite the difference in testing, is going to mean that coil should last longer. At least in my head, that's the way I'm seeing it now. Whether or not the one specific that to this AV receiver, without doing tests on my own bench or anything, I really don't have much to go on other than trying to think about this logically in my head, and by all means I feel like this coil should last longer based off of the data that I'm seeing here. Okay. The other thing I checked, well, this is actually an 8 amp relay, and we can actually get the contact ratings here. Coil voltage ratings between 3 and 48 volts DC. The contact rating is actually 5 amps at 125 volts AC, 8 amps at 50 volts AC, and 5 amps at 30 volts AC. Whereas when we look at our, where is it at over here? Should be somewhere. Where's it at? Yeah, nope, that's not it. Here we go. Okay. So the what's it? D2RL2A, double pole single throw. Again, this is the one I get. 3 to 48 volt DC coil rating. Okay, those match up. We can see that as far as general use and resistive use, we got 8 amps at 277 volts AC. And then 8 amps at 30 volts DC, so, slightly higher contact rating than this over here. So that tells me that it can withstand additional spikes in current if that was to occur. If something were to fail inside on the PCB, there'd probably be some less issue with this relay going bad, So that's primarily what I'm looking at when I'm comparing the two. And then on top of that, well, we also have to compare form factor. And this is where we get into an issue, all right? So And I'm not really concerned about the height of the relay, you know, how tall it stands off the board. And for the most part, I'm not concerned about the enclosure's width or length. But what I am concerned about, you know, those things are a consideration depending on, you know, the surrounding area of the PCB itself and other components on there, or anything that could be above it. But what I am concerned about is, you know, the measurements between our pins, okay? So here goes a comparison between the two, and let me see if I can make these a bit bigger for you to see. All right, so G, 2R, L, 2A. Boom, here goes its measurements over here for the sub I chose. And then I'll increase this. We'll scroll down and up too far. We will go right. Here goes the measurements here. And this is where it gets a bit tricky. Okay, so we can see that the distance between our pins that are you know, parallel to each other, 7.5 millimeters, and no different for this one, 7.5 millimeters. That's perfectly good. That's awesome. We can also see that our pins that are in series with each other, we're looking at 5 millimeters, and then again over here, 5 millimeters. No big deal. Those pins are going to fit into the board. However, when we look at our longer distance, we're talking about 15 millimeters here and 20 millimeters here. So much, you know, 5 millimeters difference is a significant difference when you try to mount this thing. And then herein lies the issue between the suppliers that I was able to find where I could order you know, find a sub. They were all around that 20 millimeter mark, nothing in that 15 millimeter distance, you know, with the same voltage rating, similar characteristics throughout. So, you know, barring when I can actually get this replacement in, I think I could still use this. However, I will have to modify most likely these two pins over here. Okay, this pin and this pin, you know, bring them in, which we can do by, you know, laying them flat, probably soldering on our own post to the pre-existing wires, but bringing them in about 5 millimeters. And then we should be able to socket it just fine. Now, however, big caveat, I don't know what the performance is going to be like until it's actually all in and tested, and we'll see how long it lasts. But therein goes the considerations, right? If you cannot find a part specifically for it, you kind of have to go in your head, well, what can I sub this with? And will that sub need to be modified in order to make work? And do I have the ability to modify it? And can it be modified? And all those kinds of things. And the other consideration is, if I modify this, right, that's a potential failure point. So, you know, that's another risk you have to consider. That's the only way I can put it. But anyways, this sub has been put on order, and, you know, if it's the first one in now, I ordered it 2 days after ordering this, the actual one over on the left. So we're going to play a game of which comes in first, and I guarantee you it won't be the actual 981 series relay, but I could be surprised. So we'll see. We'll play the game which one comes in first, and whichever one comes in first is the one I'll solder in. And to be honest, barring when I can get back to working on this thing, even if the sub comes in after, if it comes in after by the time I'm able to get back working on this thing, we might just put it in there anyways and test it out and see how it performs. And then, you know, maybe after a series of months or a year, we can see how it performs to that point, or if I gotta crack this stupid thing back open. But yeah, there you go. Subcomponents, a little bit to do about that, and hopefully y'all learned a bit on some things to consider if you got to do the same thing. Well, ladies and gents, that's going to do it for this video. When we come back, please stay tuned for the next part. We're going to take all those components that we're going to purchase, including the suitable subs, and we're going to get them in and test them. If that resolves our issue, great. If not, we'll have to do more troubleshooting. So stay tuned to find out what happens. If you're new to this channel, please consider subscribing if you've enjoyed this content thus far. Let me know if you like this video by hitting that thumbs up icon. And by all means, leave comments in the comment section. I try to read them and reply when I can. If you're more interested on the business side of HFR, I do operate this as a business in the state of Oklahoma. Go to my Google site. It should explain what you need to do and how to contact me. If you just want to support this channel, PayPal link is in the description. Or if you want to support this channel while getting something in return, I do have a Patreon. That link is in the description, where I teach electronics principles and electrical engineering fundamentals. It's a way for me to give to you if you're giving to me. I think that's a fair trade. I also teach test equipment over on that Patreon as well. Those videos, generally speaking, do not come over to my main YouTube channel. But regardless of all those things, I appreciate the fact that you're watching. Take care and goodbye.
Mark?